So today I'm going to create the first little piece of user interface. And so this is what the game looks like right now. And I'd like to make it so that when I right click, it brings up a dialog box that has just a single button on it that doesn't really do, when I click on it, it just prints hello. And that will be sort of the foundation of all the other interface elements that I build. So this isn't a hard requirement. Okay, so first of all, we're going to do this using Scene2D. And Scene2D is a graphics library for this sort of thing, a GUI library that LibGDX provides and works well enough for, what I need. It's not a hard requirement, but it's a recommendation that you start out with that you use a skin. And a skin is just all the graphical components that, like the PNGs and also sort of the JSON data that you need to actually render something that looks decent. So there's actually one that comes with libgdx tools, and it's linked from this Stack Overflow question. If you look for default skin libgdx, you'll find this first answer has Alice Pack, JSON, all this stuff. So if you just take all that and drop it in your assets directory, a skin subdirectory or not, doesn't really matter, then yeah, it's off to, you're off to a great start. So the next thing you need to do is you need to load it. And the way you do that is you say asset manager .load skin/UI skin.json. This is the master class, you might say. If you want to just look at it real quick, it has a bunch of offsets. It says the bitmap font is this file, and these are the different colors that I imagine are referenced elsewhere in this file. Maybe not. In any case, like later on you might end up editing this file, but right now it doesn't really matter. So we start loading it here, and now down here we can say, let's make it a val, because this is something that I end up using, you'll end up using quite a lot. Can I say var? And this is the skin. And then here you say skin equals asset manager.load.get skin/UI skin.json. Repeat all that same stuff. And so now you have a skin loaded. And so now if we start the program, ooh, Kotlin 1.04 is out. Neat. Then you'll see the game doesn't crash, and also doesn't look any different. So the next thing is you'll want to sort of have a centralized class that handles a lot of the GUI rendering. I'm going to create a class called HUD, and it's like heads-up display, like in fighter planes. So I'm just going to call this HUD, and inject constructor, whatever. We don't know what we need yet. So if you look at Scene2D, one of the main things that you need is a stage. And the stage is the thing that, as you can see, receives input events and it delegates it off to the appropriate actors are like buttons and things. It's basically just any sort of UI element. So in our HUD, we need to create this stage. We say val stage. Well, I don't really need to say what type it is. And it takes not that stage, that stage. And it takes a viewport and a sprite batch. Well, we don't know exactly what we want for viewport, but for sprite batch, we already have one. There, sprite batch is taken care of. So for viewport, we want to say private val viewport equals. There's a bunch of different types of viewports. Here, this sort of determines how the UI stretches, but which so you can use a stage not just for HUD stuff, but also for you can write your entire game if it's sort of like an arcade game or board game sort of thing. There's no sort of physics engine. If it's all fairly static UI elements, I think you can make a game entirely using Scene2D. I haven't done it before, so I'm not entirely sure. Anyway, so you can do fit viewport, and you provide a world width and a world height and a camera. That second one there. So we do have one camera. This guy. And you can say, for the width, you can say viewport width cam.viewport height. And, this might work. However, the scale of our viewport isn't, this is for actually rendering the UI onto the display, and it's not, we want to use actual pixels for that. This camera here is not using pixels. It's using world units. So if you remember, okay. If you remember here, this is our only camera, and it's in meters. It's not in pixels. So we actually do want to create a second camera. Also an orthographic camera. And we want this to look a little bit different. If you call set to ortho, and for y down, we want y up, so we say false. If you look at what set to ortho does, it calls the other set to ortho with the width and height of the screen, and then down here, it sets the height, the up direction, and then it sets the position to the middle of that viewport, and then it sets viewport here and it calls update. So that's actually that's exactly what we want. We want it to be centered in the middle of the viewport, and we want it to be pixels, and that's what this does. So the problem is, I think if you try to run this now, I think it's going to complain because there's two identical bindings. Yeah, a binding to orthographic camera already configured. So you need to give Juice some way of differentiating between these two different cameras. And the easiest way to do that is just to create annotations. So I'm going to create a file called Annotations. And you can say annotation class GUICam and annotation class WorldCam. And Juice needs a special annotation on your annotation called binding annotation. This signifies that the annotation is used for binding. You'll see here it mentions that it says you must also annotate binding annotations with retention runtime. You don't actually need to do this because Kotlin does this for you. Annotations are always kept at runtime. Okay, so that's squared away, and what this means is now you can say, yep, not that one. You can say GUICam, And so now there's a way to differentiate between these two cameras. So now back over here in our HUD class, you can say, ta-da, now it uses the right camera. Okay. So there's a couple other things that are really important, and they aren't really going to make sense right now necessarily. But on your stage, one of the things you have to make sure to do, there's two things you have to make sure to do. There's, in your render method, you have to make sure to call act, and you have to make sure to call draw. So let's create two methods. There's an update method here, and a draw method. And for draw, it's pretty easy. You just say stage.draw. Update, also pretty easy. You just say stage.act delta time. And this is important because if you don't do this, the stage will never tick, and there's certain things that are animations or they change states, and it's not all synchronous. Sometimes it has to happen on a frame thing like this. So we also want to make sure, I'll move this to a separate class in a little bit, but there's also want to maintain our HUD system. And you can maybe guess where this is going. And you just need to make sure you call HUD.update with the delta time and HUD.draw. Okay, so we're still not drawing anything yet, but we'll get to that. So a lot of the drawing that happens in Scene2D is centered around tables. And this is sort of like a HTML table, if you're familiar with that. There's rows and there's columns, and things just sort of automatically position themselves, more or less. So by default, it doesn't necessarily need a skin, but it'll look a lot nicer if you use a skin. So just always use a skin. And so we need to pass in. We need access to the skin, so we need to pass that in. We need to say private val my asset manager, and then we can say, let's just call it assets. We can say assets dot. That's right. You can just say my asset manager dot. Skin? It's not supposed to be private. So now you have a new table. And one thing that I really like using the apply thing here. And so you can say, well, let's just see, let's see what happens. Let's see if this does anything. Oh, we need to add it to the stage. Add actor table. So we're not using the HUD anywhere, so I should probably rectify that. The only place the HUD really needs to be used is in HUD System. So let's just copy this guy, and in our main module, we will draw it. And I draw it immediately after the rendering system, because the rendering system draws everything that's in the game world, and HUD system goes over the top of that. So it makes sense to draw it after. So now if we run it again, okay, so I'm going to actually make this a instance variable. So let me just start injecting private val asset manager. I'm going to say assets. And then because we're going to use skin a lot here, I'm going to just convert this to a constructor parameter and then say private val skin equals assets.skin. So now if you just say skin here, okay, let's try this again. Okay, so we're still not seeing anything, but I think that's not necessarily that it's not working. So, which also takes a skin. And then you say we want to well, we don't necessarily need to center it. Then we want to say stage.add actor this. And we're gonna eventually want the table later for other things. This will be our main table. So let's create a property here. It can be a val. So stage.add actor table. So now the button's in the lower left corner, which is sort of hard to see. But I have another helper here called CenterOnScreen, and it just calls set position, and it centers based on the width of the screen and the width of the element. So you can say CenterOnScreen, and that moves the entire table. Okay, so now it's helpfully directly above the person. But you'll notice if you click on it, you can't actually interact with it. So just to make sure, let's go ahead and say add listener, and it's sort of confusing when it's actually a change listener that we want to add. And a change listener is because it's changing states from not clicked to clicked, I guess. You can cause some action to happen. Like you can say clicked. And so now when you click on it, it still doesn't work. And the reason for this is because even though we're drawing it, we aren't sending any of the actual click actions to the stage. And you have to, because we're intercepting them all already for ourselves. So if you look here, so you look in the player controller system, you can see when this class has been constructed, it's setting the input processor to this big class here. So let's go ahead and move this class into an inner class for now. And we'll just put that at the bottom. Private val main game input adapter. And so now we can say main game input adapter here. I guess first we have to move it up above. You know, I'm actually going to make this into a proper inner class. Okay, so now here I can say my input adapter, and that works. That doesn't actually solve anything, I was just refactoring. And if you remember way back, I mentioned the input multiplexer. The input multiplexer takes multiple input processors. This is very handy. So you can say input multiplexer, and then you may not have seen this, but in the HUD, if you go to what the stage is itself an input adapter. So it handles the clicks for you. That's one of its main functions. So we just have to figure out a way to pass that stage to our system here. And the hacky way to do this is just pass the entire HUD over. So in our player controller system, we can just say, hey, we need that HUD right here. So now we can say HUD.stage. So what this means is it tries to intercept, like, remember how input multiplexer works. It looks through each thing, each input processor that it has, and if any of them return true, like key down does in this case, if this returns true, then it short circuits and just returns true out of the entire loop. So we want the HUD.stage to be intercepting things first because it's on top of the rest of the game world. So if it doesn't want to handle the click, then it trickles down to the main input adapter. So now when you click on Click Me, it now does everything that we hoped and dreamed. It shows up as clicked down here, and it animates, and I can still move around, and everything's great.